Okay, so we had just gone through all those definitions and there were a lot. So let's start looking at visuals of quadratic functions and applying what we know. So we're given the graph of quadratic function and it is a parabola. Keep in mind that although my picture cuts off, there would be our lines continuing on. So if you want to put the arrows, you can. And if you have colors, bust out those colors because we're going to be drawing all over this. So first thing it asks us to find is the vertex. Remember, our vertex is going to be our turning point in our parabola. And ours is happening right down here. And it is at the point 5, -7. So our vertex is 5, -7. Our axis of symmetry is in the form x equal to h. Yes, you must have the x. So x equals because it's a line. So here, drawing my x equal to h, so it goes through the vertex. I have x equals, and the x value is 5. That my vertical line goes through. So my axis of symmetry is x equal to 5. Find the domain in interval notation. Remember, domain is the x values that can be plugged in into your equation or into your function. Okay, so it's the x values you can be. Here, because I have the arrows where my x values will just keep going and going and going. So eventually, even though my left arm is skyrocketing up, I'm going to be able to hit x equal to a -100. It'll have a point way up in the sky. And for x equal to -1,000, it'll be up even higher in the sky. Same thing happens if we go positive. If we go to positive 100, that x value will exist and its y value will be way up into the positives. So here, our domain, because it just keeps going and going and going, it's going to be -infinity, positive infinity. Make sure that you have parentheses around both pieces. We will not use a bracket on infinities because we can't actually hit infinity. That's why we use the parenthesis. We get as close as we can, but we never get there. Next, it asks for our range in interval notation. Remember that our range are our y values for the function, or our output if you're used to input-output. So when you're doing your range, instead of working from left to right, like we do with our x values, we're going to work from bottom up. And you'll notice that our function does not go below this yellow line I just highlighted. It only goes up. What is the smallest y value that we can be? Well, if I'm looking at this yellow line, it crosses at -7 on the y's. So smallest y is -7. So let's look at the biggest y. If we follow our graph up, it just keeps going and going and going and going. So it's going to keep going up to infinity. That means that our range is going to be -7, our smallest, and we can hit -7, so we're going to use a bracket. It keeps going and going and going, which means it's going to go on up to infinity. And again, we use the bracket on the -7 because we can actually have a y value of -7. Okay, graph opening up or down, looks like we are smiling. Our arms are pointing up, which means that the graph opens up. They ask if the leading coefficient is positive or negative. Well, if we're going up and the corners of our mouth are going up, so we're smiling, that means we're happy, we are positive. The vertex being a minimum or maximum. Remember that minimum is the lowest point, maximum is the highest. Here, because our vertex is at the very, very bottom, that means it's going to be a minimum. Okay. For our parabolas, when we're asked to find the intervals where the function is increasing or decreasing, remember that increasing means going up, while decreasing means going down. We're going to go from left to right. Okay, so if I am looking at my graph, I'm going to use a highlighter again. We had our axis of symmetry at x equal to -5. He is our turning point, or sorry, +5. He is going to be our turning point. We are only concerned about the x values when we are doing our increasing and decreasing. To the far left, we know we'll have -infinity for our x values. To the far right, our x values go to +infinity. We need to figure out what's happening from -infinity to 5 and what's happening from 5 to infinity. If I follow my graph from left to right, because we read left to right, on the left, I'm going that way. Which way is that? It's going down. If it is going down, that means that you are decreasing. So we just said that from -infinity to 5 is decreasing. So we found the answer to part I first, -infinity to 5. Parentheses around everything because we never put a bracket around the -infinity. And the 5 can't make up its mind whether it's increasing or decreasing. It's a turning point. Let's follow the graph on the other side. If we continue up from our turning point, we turn around, we were going down, it's like a roller coaster. Now we're going up from left to right. And since we are going up, that means that we are increasing. So we just found on the interval of 5 to infinity that we are increasing. So function going up is parentheses around the 5 and the infinity.